So if I want to kind of figure out what happens when I do a quotient to a power, right? Quotient just means division. So I'm looking at it and saying 3/5 to the third power, right? I could rewrite that as 3/5 times 3/5 times 3/5, right? As far as doing exponent goes, they work the same way with fractions as they do, with anything else. So does anybody remember, so back to like elementary school, middle school, how I multiplied fractions? Straight across, right? When I'm just multiplying fractions, I do. So I can say this is 3 times 3 times 3 over 5 times 5 times 5. Right? So put that. So, but let's write this though with like exponents, right? If I do 3 times 3 times 3, that's 3 to what power? The third. And 5 to the third. So, what do you notice about from what I got here to what I got with my final answer? Where'd the exponent go? On both of them, right? It's kind of the same thing as a product, right? I'm still just distributing the exponent to each term. So what I can write is that if I have a over b, right? If you can fit it on the line, fit it on the line. I can't. A over b to the n power. I just give that exponent to both things. All right, so a to the n, b to the n. Okay? So that's kind of the quotient property. It works the same way as multiplication. So the last one, division property. So let's write it out the same way I kind of wrote the first one, right? 2 to the fourth would be 2 times 2 times 2 times 2, right? Over 2 squared is 2 times 2. So now if we think about what happens when I divide anything by itself. So divide anything by itself, it's 1, right? So a fraction just means division, right? So if I look, I could say I have a 2 divided by 2 there, right? And a 2 divided by 2 there. So 2 divided by 2 is 1, right? So both those are 1. If I'm multiplying or dividing anything by 1, do I have to write it? No. So what could I rewrite that fraction as? 2 times 2, right? Because these ones have reduced to 1. These have reduced to 1. So I've got nothing left on the bottom but a 1. Right? Yeah, you could put the 1 on the bottom, right? You don't have. You can. And then if I want to write that with an exponent, 2 times 2 is 2 to what power? Two to the second power. So now let's think for a second. How does the 4, the 2, and then this 2 relate to each other? How could I get from those 4 and 2 to that 2? What can? 4 minus 2 is 2, right? So when I divide powers with the same base, I subtract exponents. Right, so if I think about a to the m power over a to the n power, I just have a to the m minus n. So if I look at this first one, right, what should I do to get rid of that parentheses? So I'm going to distribute that exponent, right? So I get 3 to the 6. Y to the 6, right? I have times. I'm going to distribute that exponent first, right? So even though you see, So even though you see that there's a fraction, right? Just get rid of the parentheses first. So I'd end up with x to the 8th over x to the 12th. right? So now, when I look at that, I say, okay, is there anything I need to do with the 3 to the 6 or the y to the 6?
The 3, the 6, or the y.
Anything I need to do with these two terms? Is there any negative exponents, 0 exponents?
No.
No. So I'm just going to rewrite that. Now I notice I have two x's, right? So 2 x bases. So what should I do with their powers? Subtract them. So what is 8 minus 12?
Negative 4.
-4. Yeah, so then I have a negative exponent, right? So I need to take that and move it to the bottom to make it positive. So those rules that we've been working on all last week are going to still come into play today, right? You need to keep that in mind. All of this all works together. So that'll be my final answer. Okay. So let's look at this last one, and I'll give you some time to work on your classwork. So, what should 3x to the third power squared will give me what? Okay, 3 squared x to the power of 6. So, any ideas on what I should do with this 4 and 2? Well, they're just numbers, 4 and 2. So I just want to do the division, or reduce the fraction, right? So 4 divided by 2 is 2. And then look at x to the 8th over x to the 12th. I know that's going to be what? X to the -4th, right? So I subtract the exponents. And then what happens with that z?
I was just about to say take it 1.
So it's going to be 1, right? All right, so now I've got to clean this up a bit. So 3 squared times 2 is going to be what? What's 3 squared? 9. 9 times 2 is? 18. So here's another thing I'm going to tell you, right? Your first instinct might be to move that x to the -4 to the bottom. Since we've got 2 of them up here, right? I've got x to the 6 and x to the -4. I'm going to add them together first using that property to see if that takes care of my negative, because it might, right? So what is -6 plus 4, or minus 4?
-10.
Or sorry,
2.
6 minus 4.
2.
2. I think you were right for what I said, John, not what I meant. So I get x squared, right? I've taken care of the negative exponent, so I don't have to worry about that, right?